Dear friends, welcome to another video. Today we built a humidity and temperature sensor. As you can see, we are using the DHT11 sensor, this little sensor here, which is a very cheap humidity and temperature sensor. It costs around €1, $2 to buy, and it is very easy to connect it with an Arduino and measure temperature and humidity. In this project we are using an Arduino Mega and an LCD keypad module to display the readings from the sensor. Let's start by building this project. First of all, we are going to need an Arduino board. In this video we are going to use the Arduino Mega development board you see in the picture. Now, you can use any Arduino board you like. You can use an Arduino Uno, an Arduino Due, or any platform you like, and the compatible LCD screen for your Arduino board. In this video we use an LCD shield from eKidZone.com. It is compatible with the Arduino Mega and it connects like this. It's very easy. You press down and it is ready to use. Next we are going to use, of course, the DHT11 sensor. This is the humidity and temperature sensor we are going to use in order to measure temperature and humidity. This sensor has 3 pin outputs. One is for ground, one for VCC, and one for the signal output. So we are going to connect those pins with the Arduino board, and it is very easy to read. After that, first of all, let's connect the VCC. VCC goes to 5 volts in the Arduino board. Next, let's connect the ground. Ground goes to Arduino ground, of course. And lastly, let's connect the signal output. Okay, signal goes to any pin, any digital pin you like. I am going to use pin number 22. It's that easy. You just plug 3 wires in and we are ready to power our project up and see it running. Of course, we are going to use a simple sketch in Arduino. Now it's reading the sensor and the results are those in the screen. Temperature 27 degrees and humidity 46%. The readings are now high because I was touching the sensor with my finger. In a couple of minutes it will be stable at the actual temperature and humidity readings of the environment. It is very easy, as you can see. Now let's see how to develop our sketch in order to read the temperature from the sensor. It is very easy as well. Let's go. Let's look at the code of this example. First of all, we have to include 2 libraries. The first library is the DHT.h library. You have to download this library from this link. You can go to this site and download the library from this website. The link is found in the description of the video. Of course, you can download it from there. Now that we have downloaded the library, we have to unzip it. I press unzip and unzip it in the desktop. I rename it DHT, for example. I cut and paste in the documents Arduino libraries. Paste it here. Now we can use it in our project. So next, we have included the DHT.h. We have to include the liquidcrystal.h library. This library is used for the LCD screen shield. We define the pin of the data pin of the sensor. It's pin 22. Then we define the sensor is the DHT11. and we initialize the LCD screen. These numbers here are the pins that are used in my LCD screen and work with this example. If you own an LCD crystal display that is different than mine, then it is probably you need to enter here another values that are capable of driving your LCD screen. You have to look out for these values in the internet. Then we have the setup function. We begin the screen, we print the read sensor, and we begin the sensor itself. Next, in the loop, we have two variables, float variables, temperature and humidity. We read humidity and temperature, we sleep for 2 seconds, we clear the screen every 2 seconds, and then we convert the floats here into strings in order to be printed with the lcd.print commands. The lcd.print command prints out only strings, not values, not floats, not integers. So we have to convert this float value into a string. This happens in those lines here. I have created two character arrays, and then with those commands I convert those values, the temperature and the humidity, into strings named tempf and humf, from temperature float and humidity float, and those strings are then printed. It's very easy. You can download this sketch from the description of the video, there is a link there, and you can use it in your own project, of course. Then the only thing you have to do is to select your board. For example, it's an Arduino Mega, it's an Arduino Uno, an Arduino Duo, anything you want, and then press upload to your board and you are ready. It's very easy and very small. Now let's talk about the sensor itself. As we said, it is an ultra low cost sensor, so the resolution that it can produce is pretty limited. It cannot display decimals, and it is very slow. It can be up to 2 seconds to refresh its readings. Let's see, if I press with my fingers the sensor, let's count how much time it needs in order to display the new value. Okay, still the same temperature. Now it's 25. Let's wait a little more. As you can see, it is very slow. But it is something you expect from a sensor like this of price range of $2. Let's compare it with my advanced weather station. It now reads temperature 24.2 and humidity 46. Side by side you can see temperature is very close and humidity is off, around 5-10%. The dataset of the temperature sensor says humidity is plus or minus 5% accuracy, and temperature plus or minus 2 degrees Celsius. As you can see now, we are 1.2 degrees off and 6% off in humidity. Okay, it is a very cheap sensor, so we cannot expect great accuracy. Another thing we have to discuss is the power consumption of this project. Now the power consumption is 0.39 or 44 watts and the current is 90 amps. The power consumption is very big for a project like this, for a simple temperature and humidity meter, and the main reason for that is this LCD touchpad, LCD shield. Another reason is the Arduino Mega board, which draws a lot of power, and we have to look for solutions in order to decrease the power consumption, in order this project to be able to be powered by a small battery. But next about this in the future videos. Thank you very much for watching this project. In the next videos we are going to use another sensor, a more accurate sensor, the DHT22 sensor, and compare those two in order to see which one is better. Thank you very much for watching the video. If you like it, press like in the button below or subscribe to our channel in order to watch our next videos.